Hello, good morning. My name is Stella Warue. I'm from the Water Sector Trust Fund, and I'm a program officer in charge of the upscaling basic sanitation for the urban poor program. So I'm going to proceed with the presentation. And like you can see on the slide, the photo behind the letters, we have one of the Feacal sludge treatment plants that we have for the APSA program. So before I go into the decentralized treatment facility, I'm going to give you a brief background. You find that in Kenya, 80% of the people rely on on-site sanitation. And of course, with the on-site sanitation, this requires removal and treatment of the fecal sludge. And in Kenya, we mainly rely with the private sector, and this is because mainly the government, the county government or the water utilities do not have sufficient emptying facilities. So here we rely mainly on the private sectors, who are mainly the vacuum tankers and also the manual emptiers. After this, the fecal sludge is actually supposed to be taken to the treatment facilities. And you find in Kenya, we have like 15 towns that have conventional treatment. So we have a gap in terms of the treatment of the fecal sludge waste in Kenya. And it's on this that we found that the Water Sector Trust Fund found it necessary to come up with treatment facilities for the entire country. So I'm going to give you a brief about the Water Sector Trust Fund. This is a Kenyan state mandated by the government to finance water and sanitation for the poor and underserved areas. And we mainly have 4 investment windows, which is the urban investment. We also have the rural investment. We also have the water resources investment department, and then the result-based financing, which mainly deals with commercial financing projects. My projects, my program will mainly be on the urban program. So I'll give you a brief about the upscaling basic sanitation for the urban poor. And the objective is to actually implement a concept to access basic sanitation for the household and the plot level of the low-income areas. And here, the concept addresses the full sanitation value chain. It's an investment that has been funded by the Bill Gates Foundation and also by the German Development Bank, KfW, and also the government of Kenya. We also have, we had technical assistance from the GIZ. Currently, they are not within the program. Their program ended in December 2017. So at the moment, it's only the trust fund that is really dealing with the program. In terms of the finances, they are given to the Water Sector Trust Fund through the urban program, of which the program is implemented by the water utilities in Kenya. So the target population, we mainly deal with the low-income areas. And as a trust fund, we've been able to map out the low-income areas in Kenya. We have a website that is called the Magidata website. If you go to www.magidata.go.ke, you'll be able to find all the information about these low-income areas, which are about 2,000 in Kenya. And the WSPs are allowed to make a proposal to the trust fund within all these low-income areas. So the program insists on actually having a full sanitation value chain, from the storage, emptying, the treatment, transport, treatment, and also reuse. And here, in terms of the storage, we usually do household and plot level toilets. which we give we give a monetary incentive, of which when the landlords and the plot level owners, when they construct a toilet, they're supposed to get a post incentive kind of money where they're supposed to meet the standards. So we have to have the utility going around to ensure that the toilets that have been constructed, they meet the standards. If they meet the standard, of course, they get the incentive. But if they don't meet, then the owners are supposed to cater for it. In terms of the emptying, we work with the WSPs to be able to bring together the private emptiers, the vacuum tankers. We talk to them on how they're supposed to do the emptying, how they're supposed to treat their customers, and ensure that the waste that is gotten from these low-income areas ends up into the decentralized treatment facilities. In terms of the treatment, like I said, we have, of course, the decentralized treatment facilities that we've come up with. And here, the WSP is supposed to ensure that these private operators, they ensure that this waste ends up into the decentralized treatment facilities. Currently, we have 3 types of decentralized treatment facilities that we are doing. And the first one is DTF 22. Why we call it DTF 22 is because it treats 22 cubic meters per day. And then more of its features, it occupies a small part of the land, that is about a quarter an acre. And it also flows through gravity, so it does not require electricity to be able to run. And then also the capital and O&M costs are a bit low. The other one is the DTF 50, and how we came up with the DTF 50 was because we found that some of the towns, their fecal sludge needs were bigger than what we had already designed, so they needed more capacities. So we came up with the DTF 50 that treats like 50 cubic meters per day, and it requires like half an acre. And it also flows by gravity, so no electricity that is required. And of course, the capital and O&M costs are a bit lower. Then we also have another one that is actually 75 cubic meters per day. This one came in as a result of the environmental factors. We found that some of these, our DTF required a slope, such that for these other 2 DTFs, it could not work in areas where it was flat. So we came up with that treats a bit 75 cubic meters per day. So this is the DTFs that we have. That is the layout that you can be able to see there. We have one of the vacuum tankers that is going to empty, and then you can see some of the people that are working at the DTF. In terms of the business model, we ensure that the WSPs have come up with a business model to ensure that it is economically viable. And the key parameters include mass, satisfy, and demand. This is a DTF that is actually operating within a specific low-income area. Then it must be socially acceptable. We have campaigns where we train the communities on what is coming within their area and some of the characteristics of these DTFs so that they can be able to accept this. Then it must be pro-poor oriented. Of course, these ones have been implemented at the low-income areas. Then it also must be affordable and competitive. And mainly the operators at least have to meet the O&M cost and also make some profit. Then it's a low capital and has minimum O&M cost. And also we have to ensure that it meets the safe disposal of treatment of the waste. So in terms of the emptying cost, you find that the WS or the emptiers, the people who are operating the trucks, they pay minimum amount of money to be able to empty into the decentralized treatment facilities. In terms of the capital cost of the DTFs, we have them between 80,000 to 100,000 US dollars. Then in terms of the O&M cost per year, we have like 5,600 US dollars annually. So in terms of other than just the low maintenance cost, we ensure that we've seen that the decentralized treatment facilities are within these low-income areas. We ensure that they are within the areas where we have the communities, such that if the emptying has to be done, they don't have to pay so much for the emptying to be done. Then also the emptiers or the vacuum tankers, they do not have to travel for such long distances, which of course makes the cost to be a little bit expensive. So when they are traveling near, the cost, you find that they are a bit affordable to the people that will be needing the services. Then, of course, the WSPs, they have to charge some minimal cost to the emptiers. Otherwise, they will find their ways into other places, the environment, where they can empty this. So if the fee is a bit affordable, you'll find that most of the tankers, they are going there to empty the sludge for further treatment. So up to date, we have 10 DTFs that are actually operating in 19 counties out of the 47 counties that we have in Kenya. And this translates to 26 towns that we've already done the DTFs. And we are hoping that we'll be able to do actually more of these DTFs. Currently, we've only done the first call for proposals where the WSPs apply, and then we give them the funds to be able to implement them. And within the course of this year, maybe around March, we should be able to do a second call for proposals where we can invite other WSPs to be able to apply. And we are hoping that by the end of the time, we'll be able to serve the whole of the country, that is the 47 counties. In terms of the lessons learned and the next steps, we find that APSAP is a well-tested and proven concept, and it's operational, like I've said, in 26 towns within the 19 counties. And then one thing that we have also seen is that developing the concept takes a bit of some time. For us, it took like 3 to 5 years, which wasted a bit of some time for implementation, but right now we are on course. But we've learned from it that if we want to develop a concept, you have to give it ample time. Then there is high demand for improved toilets and DTFs. And so far, we've done like 14,000 toilets. And of course, the 19 DTFs, which are, some are complete and some are still ongoing. Then we've built up relationship with WSPs such that we are able to have a working relationship with them. And we are hoping that even in the second call for proposals, we'll have more on board. Then we have been able to engage also the residents or the communities. We have capacity building workshop where we'll tell them about the project. Then we also have standardization. We have toolkits that we have on our website. If you're going there, you'll be able to see the websites that we have. Thank you so much.
Okay. Thank you very much, Stella.
Very good morning to all of you. I'm Dr. Malini. I represent an organization called Administrative Staff College of India. And it's my pleasure to share a unique model of PPP that we are piloting or testing in one of the states in India called Andhra Pradesh. This is a project that is supported by Bill and Melinda Gates Foundation, and our partners in this project are Ernst & Young and University of Chicago. Okay, so just a little brief about the state. Andhra Pradesh is in the southern part of the country, is the 8th largest state. Around urbanization rate is to the tune of about 30%, and the urban population is divided in 110 towns. In October 2016, all the urban towns have been declared ODF, which is open defecation free, and the Chief Minister, who happens to be part or leading the subgroup on Swachh Bharat at the national level, has prioritized FSM in the state. So therefore, the state, since 2016, has been thinking in terms of not just open defecation free, but going beyond. And that has really helped and to put the state on a trajectory of FSM. and it's one of the leading states in terms of implementation of FSM. So what exactly did the state do? When I say the state has prioritized FSM, what has it done? So in line with the national policy on FSM, the state also drew up a policy and expected that all the towns should own up the policy, and the way to own up the policy is through council resolutions. So each town takes a council resolution that we will implement this government order, and we will start with all the processes required to implement the policy, which starts with empanelment of all the private desludging operators, training them, ensuring they wear personal protective equipment, sex segregated data, toilet typologies, also identifying a spot or a piece of land where fecal sludge treatment plants can be put up, and establishing a system for monitoring this desludging activities, etc. Taking up communication campaigns. So there is a lot of activity both at the city level as well as at the state level. The state level provides a lot of support. There is a separate entity called Sludge Andhra Corporation which provides this support, and that really helped. I mean, that's a great lesson for other states and countries which are looking at how do you scale up in a uniform manner. If you have an entity like Sludge Andhra Corporation which is overseeing the activities and providing support, then it could be very helpful. The state has also established a helpline for the cities to contact and find out if at all a city gets stuck, then how do they go about implementing FSM? They can contact the helpline, and that provides support. The state has established a separate cell for non-sewage sanitation to further give fillip to this process of implementation. With regard to fecal sludge treatment, the state is taking a multi-pronged approach. There are existing STPs in some of the towns. So the state has taken a decision that instead of having a standalone FSTPs in these cities, they would work towards converting the existing STPs into co-treatment facilities. Similarly, under a national funding, the state has received funding for establishing sewage treatment plants. So the state has taken up design improvements to ensure that all the new sewage treatment plants that come up in the state will be able to co-treat fecal sludge. So that took care of some of the towns, and the state was left with about 76 towns where standalone fecal sludge treatment plants are planned. And my presentation today is focusing on what is the process that they have taken up for implementing these 76 treatment plants. As a first step to build confidence, because when we started working with the state, at that time there were only about 2 standalone fecal sludge treatment plants in India. And in order to build confidence that it is usually underground drainage systems and STPs are not the only solution for treatment of fecal sludge, it was important to have a demonstration project. So we went and worked through funding to establish 2 treatment plants. This is one of them, which is based in a town called Narsapur, and it is based on thermal technology, which uses pyrolysis. It is by an organization called Tide Technocrats. It's funded by Bill and Melinda Gates Foundation. So this particular project, which has a very small land footprint and could be put up in less than 3 to 4 months' time, gave a lot of confidence to the state to put its money on the table and say that, yes, this is a workable model, and we must see how we can scale this up. So I think demonstration projects make a huge impact and help give that confidence to the state to take large decisions. So how does the state go about establishing these establishing treatment plants in 76 towns? The first thing to, the logical thinking was that let's cluster these towns and have, say, about 1 fecal sludge treatment plant catering to about 7 to 8 towns. So we do a geographical clustering, and that is what was the thinking. You see this here. However, after I just started. So after this was done and the towns were reached out to, they realized that it's impossible to do it because for two reasons. One, no city wants the shit from another town to come into their town. That's point one. And secondly, the private operators would not find it economically viable to travel all that distance. And transfer stations also, there was no city which was willing to have a transfer station in its own town. So therefore the decision was that let's not go ahead with this. It was not a workable model. Let each town have its own fecal/treatment plant. So 7 packages were worked out and a public-private partnership model was introduced using a hybrid annuity model. Now, hybrid annuity model is something which we do see in large investment projects such as roads, but this is the first time that it is being introduced in FSTP in India and to our knowledge in the world. So what does this hybrid annuity model mean? The investment comes from the private sector. The payment is made by the government. However, the payment is made in installments over a period of time. Right? In short, what it means is that in most projects, an operator will come and construct a plant and probably have an operation and maintenance contract for a year or two and leave. And it is up to the town afterwards to manage it. And oftentimes, the towns don't have the capacity or the resources to manage this, and the plant will not continue to function beyond that. So in this model that we've introduced, this is a 10-year pack where the operator has his or her skin in the game. So the idea is that the operator would bid for capital cost as well as operation and maintenance cost for 10 years period. So that entire thing put together. So your capital cost plus 10 years maintenance cost discounted at net present value. The combined value of that is your bid price. The lowest bidder will get the project. And payments are made in an annuity manner, wherein 50%, you're supposed to finish your construction in the 6 months, and 9.5 years is your maintenance period. So 50% of your capital cost is paid at the end of 6 months once you complete your construction. And the rest of the 50% of capital cost and the O&M cost is divided into 19 equal installments over the next 9.5 years. So that is how the payment is made. So therefore, there is complete sharing of risk, there is commitment sharing, and there is investment sharing from both the private sector as well as the government. So what is it that the city gives in? The city gives land, the city gives electricity, the city gives support. And what does the private sector put in? Private sector puts in money, private sector puts in technology, private sector puts in operation and maintenance, and also takes up training of members from the municipality who would be able to manage the plant further. So as on date, as we speak, out of the 7 packages, letter of awards have been given to 4. And we expect that the 4 into 11, approximately about 41 plants should be up and running in the next 6 months. And the letter of award for another 2 is underway. So we are hopeful that by the end of another year's time, we will have all the 74 plants up and running. And by next FSM, we should be able to share some results with you.
Thank you very much.
Thank you.
This is not a nice job, I can tell you. But let's clap for her. Yeah. Okay, we are going to take clarifications, two clarifications for Malini. Yes, I see one there. Where's my roving mic? And another one there. So let's start with the one closest to you there. Clarifications only, please.
Hello, everyone.
Yeah. Shall we give him a round of applause as he comes up, please?
Very good morning to everyone. So I'm Ananta. I'm working with CDD for the past 2 years. I'm a project engineer. We are going to present here is on Devnahalli, which is the first FSTP in India, which we mostly focus on the operation and maintenance and what were the challenges we faced and how we overcome it. So to go ahead, so I'm going to give you the background of the study. So initially the FSTP was a joint effort by CDD Society, Borda, and funded by BMGF and the local municipality, Devnahalli municipality. So all together combinedly put an effort to put the first FSTP in India. So and the FSTP was designed for a capacity of 6 meter cube. And the plant was started in 2015 and it is in operation for 3 years now. And while during the operation, there were a lot of challenges in technical as well as institutional challenges were faced. So that put an question to us, how do we improvise the O&M? Because we can replicate the same technology everywhere, we can replicate different technology anywhere, but the problem with O&M will still the same because the fecal sludge characteristics which is going to come out from each city is going to change, from each household is different. So every time you get a load, the challenges will be different. So that's when so we started working on the challenges and we moved on to putting in efforts to bring a sustainable O&M just by giving it to a expert committee, maybe a joint venture organizations who can take over different parts of the value chain. So to give a short background about Devnahalli and its FSTP. So Devnahalli is a town which is in rural area of Karnataka in Bangalore and which has a population of 30,000. And the most of the containment systems were pits here, mostly unlined pits. That means the sludge will be more thick and dense. And going ahead, we took a survey in like a year 2014 before the commissioning was done. So it took around 3 to 5 years of desludging interval was noticed there. So as I said, it's a 6,000 liter capacity treatment plant. So we have treated so far till 2018 around 15 lakh liters, nearly 15 lakh liters of fecal sludge. That's close to 750 loads emptied from the containments of the households and the commercial institutions has been treated. And so going forward with the O&M technology, how we designed it is, we have an initial phase of solid liquid separation. From the solid liquid separation, the sludge is treated anaerobically and where it is stabilized and dewatered in a drying beds. And it is made sure that we have minimal moving parts so that we have just 3 valves around which is manually operated just to move the liquid from one chamber to the other and the sludge from one chamber to the other. And this is made sure this is flowing everything under the gravity. There is no pumps or anything is used here. And the resource recovery part, we have a treated fecal sludge that will be dried sludge which coming out. We also co-compost it with the municipal solid waste to treat it and make it pathogen free. And finally the treated water which is also used for in-house gardening post the disinfection. So there is minimal operator requirement. So like human resource required is just 1 operator is enough to handle this. And he'll be given a residence and who can operate it 24/7. So the labor requirement for this O&M goes for different sectors. There is 1 operator and occasionally there will be 3 operators required for periodical maintenance which could be at an interval of 4 to 5 months interval because it's a scheduled maintenance for each module is required. And the operator for desludging vehicle will be 2 which is under the payroll of municipality. There will be municipal operators. And for co-composting there will be 3 operators provided by the municipality who are again the municipal solid waste collectors who will be daily collecting the garbage will also work in the plant. So now we go into the challenges. When we went on to the challenges, we have operational challenges, that's technical, and then institutional challenges. So this is the overview picture of how the plant is set up. It starts from the feeding tank at the top and through gravity it flows across all the modules. So first challenge is the technical challenges which is on solid liquid separation. So as you know, the fecal sludge is anaerobically digested in the containments. So there were a lot of solids trapped to the gas bubbles of biogas gases that's coming out. So due to this, the settleability is poor, and we saw more solids even after 2 hours of retention time moving into the liquid stream. The second challenge was the solid waste. So we have seen around 2 kg in minimum to maximum of 20 kgs per truck, which has arrived at the plant, and which this abnormality in the quantity of solid waste receiving has clogged, frequent clogging of screens, which is require frequent cleaning and maintenance. Sometimes it started escaping into our sludge line, and so that blocking were occurred. So most of this municipal solid will be sanitary napkins, pads, cloths. Then we have seen blades and sticks, which usually obstruct the valve operations. So due to this migration of solids in the liquid stream, the liquid treatment parts, which we have a ABR, anaerobic baffle reactor, and an anaerobic filter, and a planted gravel filter, there was a lot of solid silt accumulation inside was noticed. And because of this, so we were needed to put on a lot of effort, and a short duration of cleaning was expected. So usually this was planned for a 1 year cleaning process, scheduled cleaning, but it came in a shorter time, like 6-7 months itself we were supposed to clean this. And in terms of PGF, we were cleaning it once in 2 years, but it came in 1.5 years. So that there was a shortage in time, and plan which we had was not exact. So going on further, there was valve back blockages, and the corrosion of valve was also there. So we went on to change the valves once. So we found that plug valves are more stable than the gate valves, which is like cup valves or ball valves, for the fecal sludge especially. Then when the plant is designed with the anaerobic digestion, there will be a 10 days retention time in the tanks. So due to this 10 days retention time, when we open the sludge valve, so the sludge won't flow under gravity. Sometimes you need to make some efforts to make sure it flows, but there was some solidification happens. Then we had efforts to make it flow under gravity. So other challenges was on the drying, sludge drying. So mostly there were slower drying rates were noticed, and there were algae formation on the sludge, and there was a lot of sand loss. Whenever we harvest the sludge from the drying beds, there were a lot of sand loss has been noticed. So going ahead with the institutional challenges. So institutional challenges, first we would highlight as the reduction in plant utilization rate. So we expected around 2 to 3 loads per day that would come to the plant, because we have a plant operation supported by a municipality truck and the private operators. But the truck, the load we receive will be mostly from the government, and the private will be very less. And then there were truck stoppages. Since we predominantly depend on the municipality trucks, the trucks were sometimes halted or repaired, or some insurance covers were not claimed, so the truck were put in 2-3 months of stoppage periods, where the plant utilization also gone down. So there were labor strikes apart from that, and also whenever there is a retrofitting issues or some modifications required in terms of operation, we had an issue with fund mobilization through municipalities. So for example, this will give you a background of how the plant utilization was affected by the private operators. Especially around 750 loads we received every month, and total in years. So we got around 83% of the loads come from the government trucks, and just less than 20% comes from the private operators. So in order to solve all these issues, the TMC municipality gone ahead with putting 4 resolutions in place. So one is outsourcing the O&M to the third party, which can handle truck operations, plant operations, and marketing of the byproducts. Yeah. And the second is regulating disposal at the STP. So making sure that private operators are licensed, and only the licensed operators can dispose at the plant. And then monitoring standards for construction of OSS. So as I said, most of them are pits and septic tanks. There was no control over the sizing of the containments and what way they build it. So to make sure it is built properly as per the design standards, the third resolution was in place. And fourth was to collect the desludging fees through the property tax. So if they are paying around 1,000 rupees in that, so that will be divided every month or every quarter and collected with their fees of the property, so that it is not a burden for the household to pay anymore. But due to several factors, with the central government approval, state government approval, and the policy process takes long time. The municipality and the organizations involved in the operations were able to achieve the first resolution, which was outsourcing of O&M. So outsourcing of O&M was again a little bit a tedious process which we gone through, because it took 1.5 years just to bring out the proper RFP and the roles and responsibilities clear for who do what and what are the roles of the entities who will join the process. And after this, then the bid was called for, and it took almost 6 months for a proper bidder to find, and a consortium of 3 operators, 3 entities came together and took this O&M approach. And here we have Kamavida, who takes over the truck operations, and CDD, who takes over the operation of the plant, and Cube Bioenergy, who takes over the marketing of the end product. So finally, when we talk about the O&M, finally the thing that comes to our mind is the costing. So initially, before, I'll just take 1 more minute. Yeah. So when we talk about the costing of O&M, so initial practice before this tender was awarded, it was only the operation of the plant was taken up. The rest of all the control, like marketing of end products, truck operations, everything lied with the municipality. And that cost was like only the operation, which would cost around $7,000 a year. Then we found that in order to optimize all these factors, so we need a joint tender and an institution which can cover all these 3 aspects of truck operation, plant operation, and marketing of byproducts to cover the revenue. So we roughly made the effort of putting truck operations O&M together. Like 45% of it goes to the truck operation of the overall cost, and then 30% goes to the plant operation, and the remaining 15% or 20% goes to admin and other consumable costs. So how we solve the solutions in institutional challenges is post-tender, we were having a proper truck operation ensured by the Kamavida and CDD in place. That means more regularized loads are coming to the plant. Then in terms of sorting out the labor issue, the agreement was made between TMC to provide on timely basis for regular maintenance and operations. And then the operator of the salary, to avoid the labor strikes, the strikes were due to the delayed payments and those things. So in order to solve that, the labor salaries were still under the payroll of municipality, but it will be paid through the contractor so that they get on monthly basis. And a lot of awareness campaigns were conducted, and the gaps in the FSM chain were covered by converting the town into ODF, that's open defecation free status, by converting insanitary toilets and providing access to toilets to households which doesn't have earlier. The final technical improvements in order to solve the slurry movements and all those things. So we replaced gate valves with plug valves, which was more operationally feasible. And then we increased the capacity of the feeding tank so that we can hold 1 or 2 loads additional together to meet the retention times. Then to prevent the sand loss, mangrove tiles were in place in that. And then solar roof was installed to enhance the faster drying here. And the lessons learned from this O&M is, integrated O&M is what makes a plant sustainable. And choice of technology. So many technologies are in place in different parts of the world, and we adopt many technologies. But the technology in relation to fecal sludge treatment, it's always a batch mode operation. So that the technology should be suitable for stoppage and resting periods and restart periods. And then the backup plan for O&M. So which you have planned already might be affecting back and forth because of the characteristics of fecal sludge varying quite a lot. So that there is a preparedness should be there. So you should be ready with contingency funds to meet that O&M changes and the plan, so that you should be ready with that. And sustainable model will be achieved through stakeholder engagement and strong institutional framework. And finally, the overall O&M, it should be adaptability should be the key factor, so that you can sustainably run a treatment plant of any technology of any different perspectives in any scenario. Thank you.
Give him a clap for ignoring me. Thank you very much, Anantha. I allowed him to go on because I was thinking in my head, what was somebody doing with a stick in the toilet? But anyhow, the engineers can tell me about that when we are done with this session.
Good morning, everybody, and thank you for coming to this session. This presentation will mostly be about the result of 2 first years of operation and maintenance of humification bed, what is also called planted drying bed, and it takes place in Laos. This project is still ongoing. It is ending this year. You can see the funding agency here. We can thank the city of Vientiane. It is the main city of Laos. And they provide, at least they provide the land that is very expensive currently in this kind of city. The International Association of Francophone Mayors, which is linked with the Paris Sanitation Utility and the Water Agency of Paris, and so they supported financially this project. And my name is Pierre-Henri Daudan. I am from SIA Consult, and I am the FSM expert on this project. So let's get started. Before to talk about the technology itself, I would like to give you some overview of the general project. So you can see that Laos is in Southeast Asia. It is mostly agricultural. The economy is mostly based on agriculture. As you can guess, most of the sanitation relies on septic tanks. 5 years ago, there were no place for discharging, no FSTP, just a dumping site very far away in the north of the city where nobody went. There is about 80 trucks. There is about 80 trucks working into the city. And we can also notice that since a decade, they are suffering, the agricultural sector is suffering of the massive use of chemical fertilizer for years. This chemical fertilizer coming from the neighboring countries. So we have a need for agriculture. We have a need for strengthening the soil again, and we have also a need for treating the fecal sludge. The project is like, I mean now all classical FSM project, dealing with several components, technical components, but also institutional with the setting of regulatory framework, involving and pushing for more recognizing of the FS operator, capacity building. So communication is not really communication. We can more talk about marketing to help the operator to work better. And the component, technical component with humus production plant. I would like to show you just some outputs, just for you to have a global view on the project. So there is now a new municipal decree for regulating the sector. We didn't really put this certification process. We prefer to go for a labeling process to link this administrative need with also a marketing willingness in the project for supporting the operator. So certification is linked with a label. We are talking of the good fecal sludge operator into the city. This strategy was done for involving and building trust with the fecal sludge operator and not giving the impression that we are only asking from them without giving anything. So we wanted to put obviously some monitoring tools in place, and we went for very simple monitoring tools. Why? Because simplicity, it is cheap. It is also cheap to manage, and it can be very efficient. So here you can see just a GIS map. We can do only by recording from where is coming the truck when he enter in the FSTP for discharging. So just with this kind of map of Vientiane, you can see that here maybe a second FSTP is missing because nobody from this place is coming in the FSTP here. We monitor also, it's easy to monitor who is coming in the plant and to ask why they are not coming when we see that months after months there is some difference. And we monitor also everything that entering and going out of the FSTP. It is also very easy to monitor now for the staff with cell phones, with pictures. And with pictures, we can do really a lot of conclusion and a lot of decision based on just on the picture. Let's talk now about the treatment process. So you can see here pictures of the FSTP of Vientiane. So it is also called planted drying beds. There is no so much planted drying beds currently in the world for treating the fecal sludge. There is a lot for treating activated sludge, but not so much for treating fecal sludge. And maybe there is 4 or 5, I don't know. But there is even less fecal sludge like that, a fecal sludge treatment plant like that, that have 2 years of operation and maintenance, and where we can monitor and capitalize on the whole cycle, including the extraction phase of the humus and the restarting of the bed. So let me explain you in 2-3 words. The trucks are coming here in this ramp, and they are discharging their sludge into this flushing tank. So the flushing tank is upper than the planted drying beds. So it means with this flushing tank, we can flush the flushing tank, and we can have a quite good hydraulic distribution in all the beds. And you can see on the pictures, on the video, how it looks like when we flush from the flushing tank. So this picture, it was just the hydraulic test we did 2 years ago, just after the construction. Some key data on the FSTP. So you can see it is designed for about 100 cubic meter per day. It cost 800,000 euro. So 1 euro is about $1. And these 800,000 euro include the construction, but also the supervision, the design, and also a support for the 2 first years of operating and maintenance. Because as you will understand, operation and maintenance for this kind of process need to be supported financially during the commissioning. I like to show you some pictures from the beginning. So these pictures, there are different phases in the commissioning of this kind of treatment process. So you can see how it looks like in February 2017 and months after months. So here you can see that only pictures are very good monitoring way because you can count density, elevation of these reeds that are growing. After 2 years of functioning, now we can make a statement. This is what we receive. So we designed the plant for 120 cubic meter per day, but even with all the framework we build, we are not reaching, we are reaching only 55% of the loading rate. It will have consequences on the business plan. Something also interesting, it's this peak during the rainy season. That is very difficult to assess precisely during the feasibility studies. And this has also a huge influence on the business plan. What you can see here, it is a quite huge block of humus. It's what we extract 6 months ago from bed number C. It is about 70 cubic meter of humus, 1 year old. What you can see here on the market in Vientiane, it cost between 10,000 and 15,000 euro. And it's what we get after 1 year. After 2 years, we get more. After 3 years, we get more. And after the whole cycle of all the bed, we will reach the production level, the daily routine for the production level, and we will get 700 cubic meter of humus per year. So it means that after 7 years, what you will see here will cost about 100,000 euro. We did chemical analysis. We did 3 types of analysis: agronomic value, EV metals, and disinfection regarding helminth eggs. And all the indicators are very good. Because it's a very sensitive question, we went for the Paris utility lab to make the analysis of the EV metals. And they did, if you remember the Medvedev table when we were in school, they did for each element, they did several analyses, so it's very safe. And for measuring helminth eggs, we went to the University of Barcelona because they have specialists that can identify if the eggs is alive or not, even if the WHO regulation, at least from the 98 one, it is recommended to go only for total eggs. But it is very interesting to see that just after 1 year, we have no eggs that are alive. The percolate treatment, it's not so interesting, but we have very good result also. Just focus maybe on the BOD, that we are on a 20 milligram per liter at the outlet of all the treatment. So it is extremely interesting. I was not expecting so much. Regarding the cost, because the cost is really interesting. You can see, just to give you an idea, that the cost of desludging in Vientiane, it's 10 euro per cubic meter. Currently, the discharge fee is only 5%. And we know, based on the market study, that the cost for selling the humus will be between 0.2 and 0.3 per kilogram. So based on that, we can see where we are from the profitability and from the balance. It's also interesting, when you run this kind of business, production business, to think in fixed cost and variable cost. Variable costs are linked with the extraction phase, while fixed costs are linked with all the team, the salary of the people, the electricity. It's relatively constant, whatever the loading rate is.
Okay. I guess
1 minute?
1
okay.
minute, okay, 1 minute only. Okay.
So here you can see the red one is the cost according to the cubic meters that are treated. And the black one is the incomes. And somewhere the incomes are going up to the cost. And with the current economic situation, we know that we need, if we have this kind of assumption for the incomes, we have the balance when we reach 75% of the loading rate. But it is not unrealistic to change because this is very low and this is a pessimistic value for the sales. So if we go for something more realistic, you can see that the fecal sludge treatment plant, the production industry becomes profitable when we get 40% of loading rate. So currently we have at 55%. It illustrates the strong link you can have between putting an efficient framework that will push all the MTers to come to the plant, and finally the rentability or the balance of the FSTP.
Okay, now I'm going to have to stop you so we can give the audience a chance to ask some questions. Shall we give him a clap? And I'm sure you will have a lot of questions for him.